In this video, we will tune the parameters of a lithium battery cell model using Simulink design optimization. A common model structure to approximate the performance of a chemical battery is an equivalent circuit, which typically includes an open circuit voltage such as this EM, series resistance R0, and one or more parallel RC branches. The problem is that we want this model to match measured data for a particular battery cell with very high fidelity at all operating conditions, which is needed for designing controls. We have several elements in this circuit, and their behavior is not constant. In fact, they vary dramatically based on the operating conditions and the states of the battery. One way to handle this behavior is to define these parameters using lookup tables, such as this one for EM, the open circuit voltage, versus state of charge and temperature. To solve this problem, we can use Simulink design optimization to automatically tune the parameters of this model, so we can make the simulation match the measured data. Let's take a look at how to do this for one of those temperatures. There are several steps needed to estimate parameters. First, we need to import our measured data and select the data that we want to use. Second, we need to identify the parameters and set their valid ranges. Third, we may adjust some settings and then begin the estimation. And finally, we can validate the final parameters with measured data, ideally with independently measured data sets. Let's take a look at this in Simscape. Here's an example model that can use the transient data. Inside this model is the equivalent circuit structure. Each of these elements uses a lookup table, as I mentioned. The input to this model is measured current, which drives the cell model. We also include measured voltage, so that we can compare it with the simulated voltage on a scope. On the results, the blue lines are measured data, and the red line is simulated voltage, given the initial table values that I showed. You can tune parameters for a model by using the parameter estimation tool, part of Simulink design optimization. I have already created a parameter estimation project for this problem, so I'm going to load it and show you how I set it up. Here's my saved estimation task. I've previously loaded in a transient data set to this tool. Here's the voltage plot, and here's the current plot. Here I've set up the variables that I want to tune. Each of these has initial guesses and constraints that I've set, indicating the valid range of values for each. Then I've set up an estimation task. You may have multiple of these, in case you wish to have more than one step in your estimation process. In the estimation task, you can select which data sets you want to use, which of the variables you want to adjust, any initial states that are required for the model. Here you can set up the estimation options, including the algorithm that you want to use. You also have the choice to use Parallel Computing Toolbox to speed up the estimation. I'll go ahead and use that. I've already started the MATLAB pool so that I can use all 8 cores on my machine. Now let's start the estimation. I'm playing back an animation of the estimation at accelerated speed so that you can see the entire process in a short period of time. Here is the final result, which gives a close approximation of the measured data we provided. The tables of each parameter have been updated, and now they take shape based on the measured data. Using Simulink design optimization, we've now automatically tuned the parameters of the Simscape equivalent circuit model to match the measured battery data.